One of my favorite features of Pandas is its ability to represent categorical data using the categorical type, much like the factor data type in R. In this video, we'll see how categoricals work and when you should use them. A categorical takes on a limited and usually fixed number of possible values, i.e. categories. To motivate this data structure, suppose we have 4 cars, and for each car we have its VIN number, color, and size classification. Our goal is to store each set of data using Pandas. Now, VIN numbers are unique identifiers for cars, so we actually don't want to use the categorical data type to store VIN numbers because each VIN number is unique to a single car. In other words, VIN numbers aren't categories, they're unique identifiers. So in this case, it'd be better to store them using a plain old series of strings. In the case of colors, this is a classic candidate for categorical data, since we have a limited selection of colors, and each color sort of represents a collection of different cars. We can build a categorical easily using the pd.categorical function, very similar to the pd.series function. If we print the categorical, we can see the values and the unique categories, blue, green, and red. Note that this is not a series, but you could make it a series just by wrapping it in pd.series. By default, when you build a categorical, Pandas sets the categories as the unique non-nan values in the data. But if you want to set the categories explicitly, you can do so using the categories argument. This is especially useful if, for example, your website or dealership supports more colors than the cars you have in stock. So you could build a categorical like the last one with the additional categories black, orange, and yellow. The categories parameter is also useful because it lets you organize the order in which categories should be displayed, which could be handy for things like plots or reports. Without specifying the categories parameter, Pandas displays them in lexical order, which basically means A to Z. But maybe you want to report them in a different order, like bright to dark, in which case you can build the categorical like this. Now let's talk about car sizes. This is another good candidate for using the categorical data type. It's a lot like colors, but with one key difference. Car sizes have an inherent order, whereas colors don't. Now, I did say that you could order the color categories to your liking for reporting or display purposes, but in no means did I imply that the colors themselves have an inherent order. Orange is not more or less than black. Blue is not before or after yellow, and so on. By contrast, sizes have an inherent order. So when we build a categorical, we'll want to specify the categories in the correct order and set the ordered parameter to true. Now when we print sizes, you'll notice that the categories are reported with less than symbols, indicating that they have a meaningful order. This is really cool because it means you can do things like compare sizes less than extended and get back a Boolean array. Now it's important to note that categoricals don't have .loc or .iloc accessors, so if you wanted to subset sizes as those less than extended, you'd have to do it using basic square bracket notation like a NumPy array. Although you could create a series with a categorical index like this. In which case you could do something like sizes series.loc open square brackets open quotes mini. Another really cool benefit to using categoricals is that you can one-hot encode them using Pandas getDummies function. For example, if you call pd.getDummies on sizes, you get back a corresponding 4-row data frame of zeros and ones, where ones indicate the size corresponding to each row. If you're not familiar with this format, it's a really common input structure for a bunch of machine learning models.